Okay, good afternoon, everybody. We are going today to look at activity 144 from our CSP curriculum, and that's the Python Imaging Library API. So basically, I'm going to walk through this entire activity in this video, so it's going to be a little long, and you can feel free to skip to the section that you need the help with, but I will offer insights and observations throughout this video on this particular assignment. So here's what we're going to start with to prepare for this assignment. One thing you need, of course, is the source files. Make sure the source files are downloaded and saved into the same directory that you'll be placing your Python code files into, which usually should be your working directory. So to ensure that, one of the things I always like to do is I like to go to my Canopy editor, and I'm going to rearrange this in a second, but I like to go in and save as, and then make sure that it's in the correct directory. Right now you can see I'm in GitHub. That's not where I want to be. I want to be in, I have a special folder for all of my production files. I call it, that's this one right here, and I have one for this one, and then this is where I would have that code. So I'm going to save this one. This is going to be 2017 video 144. All right, so that's going to be the name of the Python file I'm going to start with. That way, I know that I'm in the correct directory when I do these videos. Okay, so now that we're done with that, we're going to skip a little bit of this introduction thing. We're going to start a log. So just like before, we like to start logs in our class that I teach. We like to start logs with %logstart-ort, and then we do the first and last name, first initial last name, assignment number.log. And if they're continuing it, I also want to point out that if you are continuing a log, you also can type the word append to the end of this. And if it's a new log, it'll obviously start it. But if you are continuing something from a previous class, you can type append and it will continue that log that you started the previous day or days ago. All right, so logging is started. Now, let's take a look at this. So remember, we just came from 143 where we used Numpy, and we learned the way that Numpy stores image data is by using arrays that are in arrays. So a lot of explanations can be heard back in that video, but also please make sure that you understand how it kind of works and how that information is stored through here. So in the activity, we used how to use nested for loops to conditionally change color values by individual pixels. We use Matplotlib and Numpy libraries to accomplish that task. The if structure was inside a for loop, which is inside another for loop. Explain the purpose of these structures: outer for, inner for, and the if, the algorithm used to turn the sky pink. So remember, we saw that in the previous activity. So if you know that you've done 143, you know that there was a code that basically analyzed the color values and added up the individual RGB values, and if the values themselves exceeded 500, meaning that the color was closer to white, then it changed it to a magenta in the example. So you can always go back to the video and see how that code works and what that is. But that's basically the idea behind number 4. So it's kind of asking you to think about that. Now, number 5, a lot of things to write about number 5. So here's the deal, and a lot of vocab words at the same time. A software developer's job usually includes learning how to use other people's code. It is often much quicker to find and learn how to use code that someone else has created than just create your own. That's completely understandable. You'll notice that in most of this course, we have been using code that's already written for us and making little changes to it, and that's very common in the software industry, so it's not something that is that's out of the ordinary. We're going to use the code from PIL, which is short for Python Imaging Library, to perform image manipulation. So you'll see in the code what we're going to be doing this. Now remember, an API, what is an API? It's an application programming interface. It's a way for programmers to share their code with other other programmers. In our object-oriented libraries, an API specifies the methods of each class. So you could think of the API as a collection of what the program, or the module in this case, can do to the objects that it creates. Okay. It tells you how to use someone else's code. PIL is like Matplotlib. That is also an object-oriented library of code. Object-oriented code creates and manipulates objects, which are data structures defined in the code. PIL's objects include images. The Matplot library's objects include figures and axes. So you see we're using different modules to accomplish something similar and have them having their efforts combined to do something new. All right, so for object-oriented code, the API lists attributes methods for each class. Almost always, at least one of the methods instantiates the class. Instantiation means creating an object, something we know already, also known as an instance of the class. And the instantiation methods that do this are sometimes called constructors. Okay, that's a new one for me. It's a method for creating an object in a class. So think of those are that's the initialization function. If you watched my video on 141, which is kind of like me defining a pretend API module, then you'll know that we had an init function. That's usually the constructor function. Okay, So, continuing. Although you are learning to manipulate images, the primary objective is to understand how to find, select, and use API documentation. These skills will enable you to learn how to use other people's code. We will use 9 methods and 1 attribute from the API for the PL.image class. Refer to Table 2 in the reference card for PyPlot and PIL, which I actually have open in a separate tab. This is the reference card that they're talking about. We're going to refer to that reference card and in the following table create a short description for each of the methods that do not have one. The 3 rows without method names will be used in the next step. So we have method and short description. So if I go to my card, I'm looking here, this is an open method. So if I look at my card, if I go down, I can see here's the open method. This is for PIL. What does it do? It creates a new PIL.image object from a standard image file. Okay, creates new object from a standard image file. Right? What does new do? It creates a new PIL image object of a solid color. For example, to create a 100 by 200 pixel image with all pixels set to RGB 555 with this transparency of 0, we would do this particular set of arguments. So this creates a new image. So in other words, think of it as open is going to use something that already exists. This creates a new image from arguments. And the arguments, of course, are on the card. We don't have to worry about retyping the arguments. Don't worry about that. All right, crop. What does crop do? It makes the image smaller size. Crop, just like in your phone, if you want to screenshot something and you want to crop out everything else other than the dialogue or whatever part of the image you want to send to somebody, you would crop that image. So crop would do the same thing. All right, convert. What does convert do? Convert creates a new image like image 2 but with format specified. So for example, that's a great way to add an alpha channel. Alpha channel is a transparency channel, in case you didn't know that. So it converts a RGB to RGBA, for example. That's one of the things that it can do. What do you think resize does? It creates a new image that interpolates from image 2. So in other words, remember, interpolation is when you have to predict certain pixels. If you make an image larger, if you make it too large, it becomes pixelated and blocky, and you can see what that looks like. Whereas interpolation would kind of smooth those edges out. So it creates a new, or changes the dimensions of an image with interpolation. All right. What does rotate do? It creates a new image rotated by an angle. Okay. Rotates an image X degrees. Right? What does paste do? Changes image 2 without creating new image, pasting the top left of the other image at given coordinates in image 2. It uses the masks alpha channel as well. So think of this as if we had a 1000 by 1000 pixel image and we were pasting on top of it a 100 by 100 pixel image, it would take that 100 by 100 image and paste it into the top left corner of the image. So pastes an image onto another image for, nice and easy things, right? Save. What does save do? What do you think save does? Right, it writes the image to the disk, and file name should be a string with a standard extension like JPEG or PNG. Okay, saves image to disk. So if you create an image and you want to save that image for future reference, you can use the save function to do it. And there are 3 blanks for 3 additional functions. So I'm not going to trouble you with doing that, but if you kind of look and see what are the options that you have, these are all the PIL class. So the 3 blank lines, as it says, 3 rows without nothing we use in the next step. So we're going to continue with the next step. So there's 4 kinds of documentation. There's official, third-party, tutorials, and problem solution-specific documentation. So, for example, the video you're watching is considered third-party documentation because PLTW is not making it. It's a teacher of a PLTW course that is making the video. Official documentation is usually among the best references for using a library. Official documentation is produced by the person or group who created the code. Third parties obviously would be created by somebody else. We're supposed to, in this problem, and we're not going to cover this part in the video, but what we're supposed to do is use this website, which if I click and open it, you can see that it is a Python imaging library handbook. Now, no, you do not have to memorize this book, okay? And this looks intimidating. But all you really have to do is go to the PIL image class and find 3 methods that are not listed in that table and add those 3 methods to the rows. That's all you really have to do. So if I go here and I say, where is the PIL imaging library module, tutorial, and what are the references and what do I have access to, and so forth and so on, then that is where you can accomplish that. So here's the overview, for example, right? And then here's some of the things that we can do as an overview. We can also look at what are some of the things that we can do, image display, and so forth. So you can browse that on your own and check out where you can find that information. Okay, continuing now. Another place to learn about libraries from third-party documentation. New Mexico Tech has produced excellent documentation of PIL. So referring to section 3 of the documentation, here at this, the attribute size is listed above in step 5. What is another attribute for every PIL.image object? So if I go to creating an object of the class image, right, if I go to that particular section of the page, what are some of the information and things that you can do? So also I want to point out, when you're looking for particular objects or things in a document, you can always hit Control F to bring up your search bar. So here's your search bar up here. And so if I'm looking for, if I go back to the assignment, if I'm looking for size, and I go S-I-Z-E, it'll show me where in this document. If I look in the scroll bar on the left here, I can see where in the document does the word size show up. Okay, so in this case, when I look here, image.new mode size creates a new image of the given mode and size. If a color is given, all pixels are set to that color initially. The default color code is black. So there's a couple of things that you can do with that, right? So browsing documentation is extremely important for using and learning new modules and things that maybe you'll learn outside of this course. That's how you can learn about how to use that. All right, so we have been provided, kind of skipping ahead a little bit here, we find tutorials. You can find number 8, answer that as well. For number 9, you've been provided a reference card for PyPlot and PIL and 3 of the best references available online for PIL. Usually when developers find a module to use, they still have to identify useful documentation. Find one additional PIL documentation resource for the internet search. Good search terms are PIL, Python. Basically, Google those things and try to find something that shows you information about this and what the author is intending. So you would fill that information out here. Okay, now let's get into the actual Python part. So as we complete the rest of the activity, we're going to be using various sources of documentation as the others appropriate. So we'll probably be sticking to the code from, for the card for the most part, but let's go ahead and get into the Python portion right now. So figure 1 of the reference card for PyPlot is reference information about 3 Python code libraries, Matplotlib, Numpy, and PIL. Based on your teacher's description, what is the summary of the purpose of these libraries? So think of Matplotlib as the displaying of an image, Numpy as the storing and manipulation of the image, and PIL as the processing of that image. Okay, so in other words, the opening, the saving, the cropping, the changing, Numpy as the, well, let's put it all as an array, and Matplotlib is our way of displaying and showing the user what the image looks like. Okay, so we're going to obtain code and images provided activity 144 in the source files as directed by our teacher. Open and execute the eartheyes.py program. So let's do that. So here we're in a Python video. We're going to open up the eartheyes picture and the program, and you'll see here it's importing PIL, Matplotlib, and also OSPath. So it's not importing Numpy for this particular thing, but it wants us to execute the code. So we execute the code, and we get, where is it? There it is. We got 3 images. Look at that. We got one. We got an image of a student zoomed in with eyes, and then we get a second image which has 2 views of Earth, the United States in particular. One that's got, you notice one's a little bit more grainy, and one's a little bit like that. And then we've got a third one with, oh, look at that. That's the student with Earth's eyes, Earth as eyes. That's kind of cool. So basically, this particular program generates 3 images. It generates, you know, what it looks like before, and then what we're doing with this, and then a processing that takes this image and does that. So also notice that this is the same image. This image and this image are from the same, but this is a zoomed in version of that. And we can examine the code and break down how this program accomplishes all of that in due time. So let's go ahead and go back to the documentation of the activity and take a look at this, right? So the program paste image, all right, so figures below are each labeled with 3 variables from eartheyes.py. The first variable in each case is a Matplotlib figure. The second and third variables are the axis subplot objects. We've talked about those items in previous activities. So fig 0, the first fig and fig 2 and fig 3, axis 0 and axis 1. So we have one image, right, with this, and it's the same image, right? This is the same image too, and even this, but this is a new image that's created from these 2 images. So remember, we have to click those. We did that already. 3 figures show that, right? Okay, so we did all that. Now, the code creating the figure above on the left is shown below. So here's a section of code right here that covers how we got the student to show up on the plot and how we also zoomed in on that right window. So we're talking about, just so we can see it to the side, we're talking about this image right here. So let's see if we can drag this. Let's see if I can resize a little bit here. Okay, that's fine. All right, so now we can kind of see it side by side. So student image equals pill.image.open and then the student file. Now remember, that was an image that was stored in our directory, so that was in our source files. So it basically is opening that image and storing it as an object, student.image. It's created from the class pill. Then we have, remember we seen where we can create subplots, and we would do with creating two objects, fig and ax. In this case, it's plt.subplots 1, 2. And then what we're doing here in this next line is we're taking the first plot and we're showing the image that is student image that we have stored and doing no interpolation on the 0th plane. So that's that one right there. This one here, we're taking ax1 and we're doing it the same way. So we're storing the same image on ax0 and ax1. Now for ax1, we're setting the ticks on the x-axis from 1050 to 1410, and we're doing it by 100 pixels. That way we don't have a scrunched up, this is referring to the x-axis here, sorry. We don't have a scrunched up set of tick marks that are every 10 or every, or worse, or lower. We only have every 100 pixels. Here, same deal, we're setting, sorry, that's just the x-ticks. For the x limit, we're zooming in on a specific 05014, and if we didn't know that, remember, we can always use the fact that the image is here, and we can also sort of zoom in. So if I wanted just one of the eyes, like this one right here, I can also draw a box around here and change that plot to that. So that's pretty close to what the original plot was. Back to home. Okay, so we can set the x limit, set the y limit, and then fig.show to display it to the user. So that's all the code basically does. So let's answer the questions based on that. Line 15 calls the function open, returns one object which has been assigned a student image. All right, practice using the vocabulary. Line 16 calls the function plt.subplots, right? It calls subplots really from the Matplotlib library. The function is being called with two arguments, and they are 1 and 2 in this case. The function returns two objects which are being assigned to fig and ax. Okay. So, the line 17, the imshow method is being called on object ax0. Recite to your partner the methods on each of the lines 20 through 24. So, again, line 17 calls imshow on x1. What does line 20 do? We'll do one example here, right? What does line 20 do? Line 20 calls the imshow method on ax1, right? And then you can kind of go down the list and kind of envision what's supposed to go into those blanks, all right? Lines 21 through 23 change the axis by displaying the single right eye in the figure above. The figure is used to identify the upper left coordinates 116296 of a bounding box. There's a vocab word for you. That's a rectangle that encloses part of an image. Okay. Now, the bounding box containing the eye. Bounding box is a rectangle that contains a particular part of an image. The bounding box for the right eye's iris is illustrated below. Now, iris, that's the center part of your eye, right? So if we zoom in on this image, we can see that we're kind of getting where that iris is based on this image, right? That's what we're doing with that particular item. What are the x, y coordinates of the upper left corner of the box? Well, x, y coordinate, x is at 1162, and the y coordinate is 966, upper left corner. Now, in the next several steps, we're going to use Python to paste an image of the Earth over the other eye of this image over the other eye in the image of the student. We'll call this the left eye of the image. Through this is the student, though this is the student's right eye. First, identify the coordinates of the iris of the image's left eye. So we're going to use and I want to point out also that this image right here is sort of an after, right? I must have already done this ahead of time, but that's okay. So we're going to take a look and see, here's our image. And then also, just to show you, when you're hovering over this, you see that the image coordinates show up on the bottom left of the screen, right? So I can zoom, pan, get home, right? So it wants us to mouse over the eye and take note of the coordinates. So left eye, right? On the left eye, I have just about, and I can also kind of do this too, right? I can just draw a box around it, right? Ding, there we go, right? That's the left eye, which is the student's right eye, as I mentioned before. So if I want to kind of get an idea where that is, I can really just zoom in on it, right? And based on that, it's about 940, 935-ish, right? So, and I look and see that the top left corner of that box is about 934 and 700, just about 701, 702, right? So I can get right up there to that 702, 936, all right? And then all the way down to 797 and 1021. So that's the box that we drew around that. Let me just go back. It's right there. So we take note of the coordinates. We can zoom in on it, which we just kind of did and just showed you, and then you would have to kind of write down what those numbers are. Now, continuing. The following part of the source code creates a figure that shows the two earths. Read and analyze lines 26 through 33. So again, there's some blanks for you to fill in, but let me kind of describe what's going on in my own words. So earth file equals os path join directory earth.png. So in other words, it's where the files are stored, the Python files are stored. It stores the and joins and figures out what the path of that file is by using the os path module for earth file. Then the image, we use the pill image open earth file. We take that variable right there and we open the image using the pill module. We then create a new object by performing the resize method on earth image to 8987 with the W and H measured in PLT, which we could use basically to find out what that is. Fig2 axis 2 is PLT subplots. We have to use Fig2 axis 2 here because remember we use Fig and X already for the student. So remember this is a continuation of that code. So we're creating a second plot, PLT subplots 1, 2, and then we're putting the earth image on the first plot and then the small earth on the second plot, and then we're showing it to the user. That's pretty much what's happening in that program. And so when we do that, let's get out of the way. Once we do that, we get this particular plot and it looks like that. So you'll notice that the second image looks kind of grainy. Okay, it looks really grainy actually. That's because we've resized that image down to 89 by 87 pixels, and you can convince yourself of that. If you mouse to the bottom left corner, you'll see that's pretty darn close to 89 and 87. This particular image, however, is maintaining its original size. So we're displaying both of those images based on that. Now, continuing. Reading documentation can be difficult because words are unfamiliar, even to the expert. Also, information might need to be found from what's it? Different. Sorry, I got distracted for a second. Let me reread this myself. Example shows they piece together information from different places. Refer to both documentation to learn how to resize objects. We can check all that information. We can see that. I'll let you do that part on your own. I know that you really want to see how the code works in this, downsampling, so forth. So check that out on your own. That's not too bad. It's just looking up information. That's not too bad. Try the following in the IPython shell and explain the output. Okay, let's do that. Let's check this out. So let's go back to, let's go back to Python, and we're going to execute some code. So resize that. So we're going to do earth underscore image dot size, and that's our output. Earth underscore small dot size, and that's our output. Earth image, sorry, dot size bracket 1, and that's our output. Interesting, right? So check that out. That's some interesting stuff. What are we basically getting from that? Well, when I type in size here, this is giving me the dimensions of the image. This is also giving me the dimensions of the image, and this is giving me just the last value of that, right? So you'll notice that if I just do size, it gives me the sort of the columns and rows, and this one just gives me the rows. Okay, so that's pretty much that. So this is one way to check our information to make sure that we're getting the right values. So you can, of course, and I already explained the answer to letter I here, in that you could just look at the tick marks and see that the size is different, but mouse over it also in their plot window, and you can see the difference there as well. So the algorithm that resize might be using, explaining that, just basically you're taking the image and just compressing it down to a smaller size. That's pretty much one way to explain it, but I'm sure you can do better than that when you explain it in your own words. Now, following portion of the source code creates the rightmost figure above figure 3. Figure 3. Showing the girl and a close-up of her pair of eyes. Read and analyze code 35 through 44 of the code. This pastes earth into the right eye and displays. So student image dot paste earth small, right? So in this case, we're using the paste function. We're using that image. We're giving a location to begin that, right? That's what those two numbers mean. And then what is the mask? We're using earth small as the mask. Okay, so that's a way to specify. There's a transparency thing with that. We're not going to go into that part of the course in this case. And then we create an image, another image plot, fig 3 and axis 3. We show the student image on one, we show the student image on another one, but then we set the limits, and then we fig show it, right? So that's where we get this. Oh, did I close it? I must have closed it. We get this third plot from it. So let me, and I know I'm kind of going ahead and showing the after results. because I've already modified this code ahead of time to do it to both eyes. But when you do this, you're only going to get the Earth on one of her eyes, and I believe it's the right eye in the image. I believe so. Yep, it is. Okay, so originally it's only showing the right eye, but your job is to get it to show over the left eye as well. So because you're watching this video, I know you're gonna be wondering, well, how do you do that? You're gonna show me how to do that? Yes, I'm gonna show you how to do that. But let's first break this code down. Okay, so we have line 37. The code refers to two pill image objects. Student image is the object with paste being called. We talked about that. We did that. I kind of already broke down what's going on with this code, so I'm gonna skip a little bit of this. But I do want to stop here and show you about this. One image is using 3 bytes per pixel. The other image uses 4 bytes per pixel. The IPython session is set 15H to determine the size of each image. So calculate the number of bytes for use representation of each image. Use the following formula, ignore compression and metadata, excuse me, width, height, and bytes per pixel. So student image is RGB, but Earth small is RGBA, so it's got an alpha channel. So that means that Earth small is using 4 bytes per pixel. Student image is using 3 bytes per pixel. So if I go back to my my Python canopy session, if I type in student.image.size, right, that gives me the pixel image, pixel dimensions, excuse me. So the width is 1920, the height is 2720, and if I did that times 3, that would be how many bytes that image is. Now if I do earth_small dot size, that's the amount of pixels. However, remember that's 4 bytes a pixel, right? So you've got to do 1920 times 270 times 3, right? And you got to do 89 times 7. And actually, you know what? You can even use Canopy to do it, right? You can do this, okay? You can say C equals student image dot size 0 times student underscore image dot size 1 times 3, right? And then if I type C, that's going to be the byte size right there. That's 15,667,200 bytes. I can do, if I do letter D, I can do the same thing for dot size. As I remember, I'm using the attributes here, right? Earth small dot size bracket 1 times 4 in this case, and then that's our size there. It's 30,972 bytes. So you're watching this video, you got a way to check your math now. So RGBA includes an alpha channel. It shows how transparent, opaque an image is. The save method recognizes file type extensions, and so you can save Earth small with the following code in the IPython session. So if I did earth_small.save and then called it small earth.png, and then if I go to that folder, let me see if I have it open already. I think I do. Nope, I don't have it there. Let's see if I can I'll have to open it up in this window. Let's check it out. So if I go to open and I go to star.star to show all the files in there, that is not stored into that. So, oh well, star.png. Earth and Earth eyes are saved, so that's a future thing. So I must have already done that earlier. Earth.small, so I say small earth.png. If you name also operation system, that's okay. All right, don't worry about that. It should save it into the same directory as you have your Python file, or your working directory. Did I have my working directory differently? Yeah, that's why, because it's in my working directory, not the file I have there. So it actually is in this folder. So that's why it pays to pay attention, right? There it is. That's my small Earth PNG image. Okay, all right. So we figured out the mystery there. It saves it to your working directory, not necessarily where your Python file is saved. Okay. So file size, the two files in operating system record the file size. So if I save them, that's how to save small Earth. You should do the same thing to that. You can compare small Earth and student in bytes to the actual files, and what's the discrepancy? There's more information that is stored in the actual file, not just image data. There's also something called metadata, which is about what the image is about, when was it created, any information that you might have in what's called like a header of it. That's what would be stored, what that additional information would actually be. Whoops, it's telling me, yes, I know, I'm recording a video, computer. All right, add lines to code to paste the Earth and image or girl's other iris. Save your code as directed by our teacher. So here's the magic part, right? So if you skip to this part of the video without learning about how to do it, that's not good. But you know, I can't change that. All right, so here you go. This is what you got to do. Okay. This information right here. Okay, where is it? I gotta find it. Open resize display Earth. Paste Earth into right eye and display. Here it is, right here. So you'll notice what I've done here. And this is the spot right here. Added code, right? We took the same image, and we just pasted it into a new location. In this case, this is where the other I was, which you would get from the bounding box that you created earlier on in the code. Then all you had to do was PLT subplots, imshow, set x, y, and fig3.show, which is why when we run that code and we get that, I know I ran it again, but we would get that same image with the other eye covered as well, and then a zoomed in version of that same image, which is why the earths are still there. So if the eye doesn't show up exactly where you want it to be, that's you have to modify the code. I would fully expect that since you'd be finding your own bounding box, that you would not necessarily be using the numbers that I make here. So if you are watching this, you may want to change the numbers to be something different, especially if you're one of my students. So it is what it is, but that's the code to help you do that. All right, guys, so if you enjoyed this video, if it helped you with the assignment, I really would appreciate it if you would like this video, and I would also really appreciate if you would subscribe to eSIMS Engineering, as we have lots of great videos that are still coming down the pipe to help you with your PLTW courses, and we're here to support you as well. Have a wonderful day, and don't forget to be awesome.